Hi, I'm Victoria. Hi, I'm Miss Isaac.
Hi, I'm Miss Hall, and this is lesson 65, Sum of a Finite Geometric Series. Finding sums of finite geometric series. The expression formed by adding the terms of a geometric sequence is called a geometric series. The sum of the first n terms of a geometric series is denoted by S sub n. You can develop a rule for S sub n as follows. The first equation has that S sub n is equal to the first term plus the first term times r plus the first term times r squared plus the first term times r cubed, so on and so on until you get to the first term times r to the n minus 1. Now the trick here is you can then multiply that top equation by negative r. What you get when you multiply by negative r is negative first term times r minus first term times r squared minus first term times r cubed, so on and so forth until the end, where you end up with minus a sub 1, the first term, times r to the n. You'll see here that all the middle terms cancel out when you add. They're just like a system of equations. We're going to add these two equations. And we're left with s sub n minus r times s sub n equals a sub 1 plus, not plus, a sub 1 minus a sub 1 r to the n. And then you can isolate s sub n, and you end up with the formula for the sum of a finite geometric sequence. Just like the arithmetic sequence, what I just showed, you don't need to be able to recreate. I wanted to show you where this formula comes from. And actually, this sum of a finite geometric sequence series formula is on the reference sheet. So you need to be able to use it on the regions, but you don't need to memorize it. The finite series, you need to memorize that formula. This one you do not. Example 5, finding the sum of a geometric series. Find the sum of, and we have summation notation. So we are adding the first 10 terms, K1 through K10. You could line those all up and add them, or we could use this formula. And for the summation formula of a geometric series, we need a sub 1 r and r to the nth power. Okay, so the first term is when k equals 1. So I will take 4 times 3 to the 1 minus 1. 1 minus 1 is 0. Anything to the 0 power is 1. So the first term here is 4. The r, the common ratio, is 3. And r to the n, well, I guess I need to know what n is. N is 10. There are 10 terms. So r to the n is 3 to the 10th power. Now I plug all those things into the formula. So the sum of the first 10 terms is equal to the first 3, sorry, not 3, the first term is 4, times 1 minus 3 to the 10th over 1 minus 3. And I would plug that into my calculator, and I'll get 118,096. Above example 6, I have the geometric series formula as it appears on the Regents reference sheet. You'll notice that a sub 1 has been multiplied into both terms of the numerator, which is different than how it looked on the front of our worksheet. It's the same, right? The Regents just distributed that a sub 1. So, example 6, solving a real-life problem. You can calculate the monthly payments M in dollars for a loan using this formula, where L is the loan amount in dollars, I is the monthly interest rate in decimal form, and T is the term in months. Calculate the monthly payments on a 5-year loan for $20,000 with an annual interest rate of 6%. Okay. So L is the loan amount in dollars. That is 20,000. I is the monthly interest rate in decimal form. Well, this is the annual interest rate. Let me make it a decimal, 0.06. And then if I want the monthly interest rate, I divide the annual by 12. And I get 0.005. And that is my T. And, that is my I. And T is the term in months. So 5 years, I've got to convert that to months. So 5 times 12 equals 60 months. Okay, now set up the formula. So monthly payments in dollars equals 20,000 over the sum of I equals 1 to T. T is 60. And the rule is 1 over 1 plus I, which is 0.005, all to the K. That can't be K. All to the, because this is K. I'm doing K equals I. Okay, K equals 1. And now for this summation, since it's a geometric series, I could use the formula on the top of the paper. I'm going to opt to put this in my calculator and finish solving it that way. Okay, so here I am putting the denominator in my calculator. I have an older calculator, so I'm going to go to Second, Stat, over to Math, go down to 5, which is Sum. Then Second, Stat, over to Ops, and I want the sum of a sequence. I'm going to type in 4 things. First is the rule. 1 divided by, in parentheses, or I guess I could just add it, 1.005, comma, I forgot to raise it to the power of K. So we need parentheses. 1 over 1.005, parentheses, to the power of, I'm going to change it to X, comma, X is my variable, and I want that variable to go from my index from 1, comma, 60. And that closes the sequence, that closes the sum. Now it's adding up the first 60 terms. Okay, and now I want 20,000 divided by this 51, or 52 if I round it. So I'm going to use 20,000, 1, 2, 3, divided by second answer, enter, and I will get that the monthly payments, it's payments, let me round to the nearest cent, it's going to be $386.66.